All right, good afternoon, everyone. Today we're going to have a little bit of a further look at financial expectation. Okay, so we had a quick look at this last week, but we're going to do a little bit more in depth today. The financial expectation of a game of chance is the average amount of money returned per game, so how much you would actually expect to earn. It is calculated by multiplying each outcome by the probability of that outcome happening, and then you add all the results together. So a simple game here first. Arm tosses 2 coins. He wins $2 if it comes up as 2 heads, $1 if it comes up as 2 tails, and nothing if it doesn't happen at all. So first, here's financial expectation. First thing we need, the probability of each thing happening. Okay, we've done this exact question before. The probability of getting a head and a head is 1 out of 4. 1 head, 1 tail, 1 out of 2 because it can happen in 2 different ways. And a tail is 1 out of 4. So his expectation, okay, well, he gets $2 for 2 heads, so it's $2 times 1.4. He gets $1 for 2 tails, so that's this one here, so it's $1 times 1.4, and 0 for everything else, so 0 times a half, this half here. So again, 0 times a half, this here, that's nothing, we can cross that out. So the amount of money you can get, well, 2 times a quarter is 0.5, so 50 cents, 1 times a quarter, 0.25, so 25 cents. Over the long run, he'll expect to get 75 cents for every game. Okay, so this isn't how much he will get every time. It's just over the long run, he'll average 75 cents per game. Okay, let's look at another one. So this time, Goran rolls a pair of dice in a game of chance that costs $1 per roll. Okay, the table lists the financial outcome for each event. So in this thing here, we have that if he gets a double, so both dice are the same, he'll get $2. If the 2 dice add up to 7, he'll get $3. If they have an odd sum, so they add up to an odd number, excluding the number 7, because the number 7 was here already, he will get $1. And if it's an even sum, except the double, because the double was included up here, he loses $1. So first, the financial expectation for this game, we need some probabilities first. So look at a table, we have 2 dice, so the top could be what happens on die 1, the side could be what happens on die 2. Okay, so to fill in the table, we're looking at sums mostly, so the first thing here would be 1 plus 1, so it'll be 2. Next one would be 1 plus 2, 3, so on and so on. You fill up the table and you find there are 36 outcomes. Okay, so there's 36 different things that could possibly happen. So first we need to know what's the probability of a double. So the doubles are this, 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 this. So there's 6 ways that can happen. So 6 out of the 36 is 1 over 6. Next, sum of 7. So that's 1, 2, 3, 4, 5, 6 ways it can happen as well. So 6 out of 36, 1 out of 6. An odd sum except for the number 7. Okay, so that would be this one and this one, this one, this one. Okay, so all the 5s. 7s we don't count because they've already been counted for in here. Try the 9s and 11. Okay, so how many squares have I badly drawn? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 36, which is 1 out of 3. And an even sum except the double. So that's all the things that haven't been looked at before. So there's 12 things left. So 12 out of 36, 1 out of 3. So his expected value, okay, well, he gets $2 for this, so 2 times 1 over 6. $3 for this, so 3 times 1 over 6. $1 for this, so 1 times 1 over 3. And minus $1 for this, okay, because he loses, have a minus. So minus 1 times 1 over 3 there. So work them out. So simplifying, we get 1/3 plus 1/2 plus 1/3 minus 1/3. These two here, they give you 0, so we can ignore them. 1 over 3 plus 1 over 2, 5 over 6. So whenever you're doing money, it should always be 2 decimal places. So 0.8333 forever is 83 cents. And then now part B, we can make a decision. On average, will he make a profit or a loss? Well, he has to pay $1. Okay, so each game costs $1. So he would expect to lose 17 cents per game. Okay, so he'll pay $1. He'll win 83 cents. So he loses this much money here. All right, next. This time you've got two options of getting paid. Option A, you will definitely get $200 each week. Option B, you've got a 70% chance of getting $500 or a 30% chance of losing $200. So in the long run, so over a long period of time, which is the better option? And you need a reason. Okay, so to do this, our reason is going to be based on the financial expectation. So for option A, the financial expectation is $200 per week. Okay, it's absolutely guaranteed. So $200 per week, that's the expectation. For part B, you have 70% chance of getting 500, so that'll be 0.7 times 500. 30% chance of getting 200, so that would be 0.3 times minus 200. Again, negative because you're losing. Work out each part. So $350 minus $60, $290. So to figure out which one's better, just which one do you expect to get more money from? Well, B. $290 is better than $200, so B is the better option. All right, next one. The Get a Life Insurance Company has only 5 customers, okay? And their details are listed below. The mortality rate, so the chance of someone dying in a particular year, is given in the table. The size of the policy is how much the company must pay the person's family if they die. We want to work out the financial expectation of the company's payout. So how much do they expect to have to pay out each year? So to do that, we find the financial expectation of each one. So for the first one, 330,000 times 0.2, that's what this number is here. So it's 330,000 times 0.002, $660. Next one for John, 450,000 is the size of the policy, and there is a 0.004 chance of happening. So that will give you $1,800. Do the same with the next 3, so same kind of idea, find the expected payout. So the total will be, just add those all together. 660 plus 1,800 plus 47 plus 1,400 plus 2,160 for a total of $6,067. That's how much they expect to have to pay out. Right? So this is actually how an insurance company works out all of their different sizes of their policies and all their premiums. Okay, so a premium is an amount that the customer has to pay every year to have access to this insurance. So if each customer pays $2,500 annually, so every year, what is the company's expected profit? So profit is how much money you get minus how much money you lose. So they expect to get this times 5 because there's 5 customers. They expect to pay out, they expect to lose this. So the profit will be 2,500 times 5 minus 6,067. So 12,500 minus 6,067. They expect to make a profit of $6,433. All right. Next one. Property owner is trying to sell his apartment. He has 4 possible outcomes. They're shown in the table. What is his expected profit? So first, to make the numbers easier to deal with, let's change all the percentages to fractions. So 25% is 1 over 4. 37.5% is 3 out of 8. That one's 1 over 4. 12.5% is 1 over 8. So all you need to do is multiply this by this, this by this, and so on. So his expected profit would be all of that. So a quarter times 8,000, 3/8 times 2,000, a quarter times 0, again, that one's not going to do anything, and an eighth times minus 4,000, okay? Loss means minus. So work out each one. 2,000 plus 750 plus 0 in the middle there, minus 500. Add it all together, he expects to get $2,250. And last of all, 400 raffle tickets are sold. There are 3 prizes. So first prize, 160, second, 120, third, 80. Find the financial expectation of 1 ticket. So if you had 1 ticket, how much would you expect? So we need the probability again. So probability of coming first is 1 over 400. Okay, if you wanted to go further and think about what happens with the second and third place draw, once you come first, the chance that you come second, your ticket's already gone, the probability is 1. And the chance of coming third, same thing, you have no tickets, so you're guaranteed to lose 1. So it's 1 out of 400. Do the same with second. So with second, first, you need to lose first. Okay, so the probability that you lose the first draw is one of the other 399 out of 400 tickets come up. The probability you win second is that your 1 ticket that's left out of the 399 remaining tickets, because 1 has already been taken out, that's the probability that you get the second draw. They cancel out, and, well, 1 out of 400 still. And probability of third works out the same if you want to consider it draw by draw though. So you lose the first prize, so one of the other 399 tickets get pulled out of the 400. You lose the second prize, so now there's 398 tickets that aren't yours out of 399. And then finally you win third prize, so your 1 ticket left out of the 398 remaining gets drawn out. Again, cancel some things out, and you're left with 1 over 400. Okay, so the expectation will be 1 out of 400, and because all of the probabilities are the same, you can just add the 3 outcomes together and put them inside here. Makes it a little bit easier. So add those together, you get $360. So 1 over 400 times $360 is 90 cents. Okay, so if you had 1 ticket, you would expect to get 90 cents. So that's all for this. Basically, the whole point of this financial expectation, this is what people actually use to determine prices. So the person in this raffle, they would have worked out the expected value, the financial expectation, gone, wow, it's 90 cents. When they set the price of buying 1 ticket, they would make sure that it is more than 90 cents. Okay, so they might make it $1, so they're guaranteed to win money. Whenever people create a game of chance, so like with the dice and the coins in the questions before, they'll always make sure the cost of entering the game is more than the amount of money you can expect to win. Okay, so it's how people price things to make sure they make money. So this is one of the very important things of probability that are actually used in the real world. I'll put some more questions up for you later. In any case, see you on Thursday. Have a good week. Bye-bye.